Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. And I came across this over at Popular Science. This should be interesting. Here's what a billion years does to glass on the moon. Yes, exposure to radiation for eons gives the stuff a stiff boost. Interesting. There you go. Chang'e 5, China's first lunar sample return mission, brought back a tiny amount of the moon's glass. I actually did another video previously on this channel, which I'll put the link to that video for your own, just so if you want to have a look at it. It's about the latest Chinese probe that landed on the dark side of the moon. So it's very interesting. So I'll pop that link down in the below the description here. Now, what happens to glass if you leave it out in the open for several billion years, but with no air and no running water? We can find the answers to that question by studying naturally occurring glass on the moon. Now, the moon may lack the features that usually weather rocks or minerals on Earth, but that doesn't make this satellite completely inert. Scientists know that prolonged exposure to radiation leaves a mark on the lunar surface. Now, new research suggests that billions of years of radiation exposure appear to stiffen lunar glass, according to a team who published their work yesterday in the journal Science Advances. Now, as usual, I'll leave the link to the main article below the video, so you can pop in and check out some of these embedded links if you want to go for a bit of a deeper dive. Makes for a very interesting read, believe me. Now, there we are, green glass spheres from the Apollo 15 mission. Interesting. Wonder why they're green. Anyone who's an astrogeologist or an astrophysicist or astronomer or something, please, I'm not a scientist, don't ever claim to be. I just love all science and sharing music. Love that too. But I love, let's be real music though, oldies. But it's just something I really enjoy. Just sharing science, and I'm a student of all sciences, and I just love it. So anyone out there who knows 1,000,000% more than me, please let me know down in the comments. The moon may not seem like an obvious place to find glass, but tiny glass spheroids riddle the lunar regolith. Yes. The rock chips and other loose material covering the lunar surface, meteoroids constantly bombard the material, melting it into tiny pools. As the molten regolith cools back down, it hardens into glass. Now, glass is more than just a brittle, transparent sheet that fills windows. Scientists think of the stuff as the result of a liquid cooling rapidly without its atoms slotting into a defined structure. Now, for that reason, some scientists consider glass to be its own separate state of matter. Well, that's interesting. I didn't know that. And even on the moon, glass does not last for billions of years without changing. Now, though the moon has neither a significant atmosphere nor running water to weather rocks like on Earth, the lunar surface is subject to something that our planet's atmosphere typically filters out: radiation. Some of it comes from the sun, some of it arrives as cosmic rays from far greater distances. Regardless, over billions of years of radiation exposure, the effects build up. Okay. I love this link. Why do all these countries want to go to the moon right now? I would suggest it's some kind of mineral. It could be helium-3 perhaps. Again, anyone knows more about it, please feel free to comment. It'll be great. Geologists have long been interested in how radiation affects lunar soil. There have been 20 years' worth of study on it, says Rhonda Stroud, a space materials scientist at Arizona State University, was not an author on the paper. Yeah, any materials scientist or aerospace engineers, when I do these space videos, feel free. Chip in your 2 cents worth, as the expression goes, because we'd love to hear from you. Now, much of that work involved taking facsimiles of lunar soil, which they call simulants, and exposing them to radiation. But Stroud says it's hard to know how individual material particles react by studying vast quantities of them. Any one little dust particle or sub-millimeter glass sphere could have its own age, she says. Things get buried, the regolith churns. Green glass spheres from the Apollo 15 mission. That's something that was interesting. The Chinese mission in that video I've linked below, they found was on the dark side of the moon. But they're saying here, like, things get buried, the regolith gets churned. Apparently that soil was much younger than on the the side of the moon we always see, on the near side. Very interesting. You should check it out. Fortunately, we have actual lunar glass on Earth in the form of samples returned by our moon missions. Most recently, we can thank the Chang'e 5 lunar lander, which lifted off from China in November 2020 and returned less than a month later bearing 3.81 pounds of souvenirs. Chang'e 5 did not land in a place on the moon that experienced many impacts and consequently did not return with much glass. Still, scientists managed to sift through Chang'e 5's bounty and pick out 5 particularly glassy particles, each one of them about the width of a human hair. They examined each particle under a transmission electron microscope, allowing them to view its structure. They also pressed a tiny probe on each particle, allowing them to test how the particle reacted to force. Now, the researchers then rejuvenated the samples by heating them up to liquid temperatures of more than 1100 degrees Fahrenheit, holding them there for a minute and then letting them cool. Sounds like a beer in an Australian summer. They repeated the same, or the opposite or something. They repeated the same microscope and pressure tests on the de-aged samples, allowing them to estimate what the particles looked like before hundreds of millions or even billions of years sitting on the moon and basking in radiation. Yes, interesting. So even glass on the moon gets to sunbake. Fascinating. Excuse me. Got to caffeinate. Now, we finally have a detailed map of water on the moon. That'll be an interesting link. Have a look at that one. Now, they found a drastic change in a property that engineers call the Young's modulus, which measures how much force a material needs to distort by a certain length. Now, if the researchers' rejuvenated samples are any indication, then prolonged radiation exposure increases the Young's modulus of the glass by as much as 70%. More subtly, radiation also seemed to harden some of the particles. That's one of the things we've got to look at when we go to the moon is the radiation, because of the limited or zero atmosphere on the moon. We've got to start getting some shelters. Yeah, maybe under the moon's surface, because I did a video yesterday on a hole discovered in the surface of Mars from the orbiter that's going around, and it looks like it's a lava tube or something like that from an extinct volcano. Now, if the moon has this again, please, any astronomers out there, please let me know, or volcanologists, exo-volcanologists, can you tell me if the moon used to have volcanic activity on it? If that being the case, maybe we could use a lava tube to set up our moon bases under there. That would be interesting, like they're talking about in that video I did yesterday on Mars. Interesting stuff. Got to look after us when it comes to radiation. Our bodies don't really agree with a lot of it. These discoveries can help scientists figure out how glass behaves in the soil of other worlds, and the research team believes that it might also help us understand the behavior of the glass we make on Earth. In fact, this paper's authors believe that lunar glass itself may soon be useful. In their vision, moon dwellers might sift through the lunar regolith for glass beads and convert them into glass they could use for their vehicles or habitats. But it is not obvious to everyone how research like this yet translates into actual infrastructure. The radiation from solar winds is very, very slow, Stroud says. I don't think we need materials to withstand billions of years. Yeah, very, very interesting. Yeah, as I say, I'm not a scientist at all. I just really, really enjoy science, and this is really interesting. Really interesting. You know, here's what a billion years does to glass on the moon. You don't really think about it, do you? Yeah. But it's something, as I said, you can imagine we do the same thing on Earth. There are materials that we use now to construct things. Material scientists will tell you this. Aerospace engineers will tell you this, that it's billions of years old too. Or millions of years old, you know, like we use it all the time. And now looks like we can start using some of the glass from the moon. Wouldn't that be interesting? All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News Update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
my brain hurts!